This segment, let's go ahead and discuss electrolysis, which kind of falls under the broader category of oxidation reduction reactions. So again, when you hear oxidation reduction, you should think that oxidation is losing of electrons and reduction is gaining of electrons. That will really help you to navigate your way through this topic a little bit. So before we really get into electrolysis, let's kind of discuss what the broader topic of electrochemistry is and what that means. So electrochemistry is just the study of the interchange of chemical and electrical energy. And a very simple example of that are batteries that you use every day. So basically they create a redox reaction and to produce an electric current. Okay, so it's alive and well in all of life. So then more specifically, under electrochemistry, we have the process of electrolysis. So that's when electrical energy is used to produce a chemical change that would otherwise not occur. So for example, if you forced a current through water to produce hydrogen gas and oxygen gas, and that reaction looks something like this. You have two waters, add in some electrical energy, and you get 2 moles of hydrogen gas and 1 mole of oxygen gas out of that. So there are two types of processes are involved in this electrochemistry or electrolysis process. So the first is production of an electric current from a chemical, and that's done by inducing a redox reaction. The second is to use that electric current to actually produce a chemical change. So recall that half reactions help you look at and keep track of the movement of electrons. So you have a species that's being oxidized, usually a metal, and a species that's being reduced, usually a nonmetal, and those two things work together to give you a redox reaction. Okay, and if you write the half reactions, then you can specifically look at how many electrons are being moved back and forth between the two elements or two species. Okay, so from a redox reaction, you can harness that chemical energy. Okay, so then in that you'll have what we call an oxidizing agent or the electron acceptor, and a reducing agent or the electron donor. So try not to get oxidizing agent and reducing agent confused with which one is actually being oxidized and which one is being reduced. Okay, so you can put these two things and you separate the oxidizing agent and the reducing agent, and then have a way to basically watch the electrons being transferred from one to the other, and you can connect them to some kind of device of your choosing to make it do work. So basically you use the electrons to produce the energy and harness that energy. So a basic application of electrolysis that happens in everyday life, it's useful for producing metal from their ores. And so one of the most common ones is aluminum. And so you can take aluminum ions with a 3+ charge and they'll be reduced and you get an aluminum solid out of that. Okay, so I wrote the electrons on this side because it's being reduced, which means it's gaining electrons. And then after you get this aluminum solid, or aluminum metal, you can alloy that with other metals depending on what it is you're planning on using the aluminum for. Some possibilities are zinc and manganese, and those are the most common. And that is the basics of electrolysis.